Sharon's doggy daycare plans to enclose a rectangular area alongside the existing building to allow extra space for dogs to exercise. Sharon has 240 yards of fence with which to enclose 3 sides of the rectangular exercise space. The 4th side is along the building, so will not require fencing. Find the largest possible area for the rectangular exercise space. Now, some of you might know the basic pattern, and that is that there will be 2 congruent squares next to each other for the final answer. But that's not necessarily a proof, that's just a pattern. So let's first off, here's the building. We're creating a rectangular exercise space. So I'm going to call this X and these will be Y. So the perimeter will be X plus 2Y. We only need to cover one of the X sides because the other one's the building. We don't need fencing there. So this is not the normal perimeter formula. Okay, so the X plus 2Y equals the perimeter we have 240 yards of fencing. Now we're asked to find the largest possible area. Now the area is XY. We can't maximize this because it's just not even a nice function yet. However, if I were to solve for X, it's easier than solving for Y, but you could choose to solve for Y. I can use that value for X and distributing gives me negative 2y squared plus 240y. So here we have A is a quadratic function. This quadratic function is a parabola. The graph is a parabola that's opening down. So it's this basic shape. And we're trying to find the largest possible area. And that happens at the vertex. So by getting the area to be a quadratic function, we can then maximize by finding the vertex. So the vertex, usually it's x equals, but this case is the variable, it's y equals negative b over 2a. The b is 240, so that's negative 240 divided by 2a, which is negative 4. And 4 goes in 24, 6 negatives reduce, 60. Y, so this is 60, this is 60. And for the x, let's see, find the largest possible area. We actually don't need to find the rest. What we need to do is we need to plug this into our area formula right here. And when we do this, we will find A. So pulling up a calculator, I'm not going to use the graphing part of this calculator, so you should be able to do the same work that I have. This is negative 2y squared, so negative 2 times 60 squared plus 240 y, 240 times 60. 7,200, that's the area. Now the y is in yards. This is an area. This would be square yards. That is the maximum area that we can create with the given fencing we have, assuming that we fence along the side of the building.